Hello everyone and welcome to another simple science video where we aim to explain simple scientific concepts. And on this video we are going to discuss about the conservation of momentum and forces. Okay? So what about the conservation of momentum? It is based on the idea that in order to change the momentum of an object or a system, you must apply a resultant force. So basically, if you have a resultant force, you're going to accelerate this object or this system in a way, and therefore, if there is no resultant force, then you will not accelerate, and as a result, the total momentum of a system is always conserved. So overall, in a closed system with no resultant forces, the total momentum is always conserved. Now I will talk about two ways in which you will encounter very often, you will only encounter in your exams that will talk about this. Talk about the ways in which you can conserve momentum. And the first way is when particles collide and they separate. Two particles collide and two particles separate. And let's get the idea that the total momentum is conserved. That means the total momentum before the collision is equal to the total momentum after the collision, as I said. So that means the sum of the momentum of the first particle and the sum of the momentum of the second particle is always the same before and after collision. Okay? And the sum of the first particle, the momentum of the first particle is m1u1, and the momentum of the second particle we call m2u2, right? And the momentum of the particles after, that is m1v1 and m2v2. Now this equation is very important, the one in bold, and you must remember that for any situation that involves two particles colliding and separating. Okay? Good. Now let's come to an example. You're asked to find v1. So you basically use the formula of m1u1 at m2u2 equals m1v1 plus m2v2. And you plug in the values, you get 2 times 10 meters per second at 5 times by negative 20, because the speed as indicated by the path is in the opposite direction, so it has to be a negative. And 2 kilograms times v1, whatever v1 is, it's positive or negative, we don't care, we just call it v1, and 5 times 5 meters per second, positive because it's going to the right, and we're taking right as positive since the start. So we then rearrange it, and then we find v1, which gives us minus 40 meters per second, which is essentially 40 meters per second to the left. Now, what if these two particles do collide and they stick together, and they continue sticking together to the end of their motion? Now let's get the idea that total momentum is always conserved again, and the total momentum before the collision is equal to the total momentum after the collision. Sorry, that was a typo. But the total momentum before of particle 1 and the total momentum of before particle 2 should give the total momentum of the two particles combined. Okay? And we then come up with this formula, because on the left side we have the total momentum before the collision, as we have explained in the previous slides. And then on the right, it's a little newer. The combined particle will have a mass of m1 at m2. So we call it, think of it as big M, and then it has one speed because it's one particle now. We call it v. So big M times v is the momentum of the combined particle, which is the same as the on the left side. Okay? So that is another very important formula for when two particles do collide and then they stick together. So you will be asked to find v. What is v when those two things collide and they move together? So we put in our formula, okay, and then we substitute the values in. 2 kilograms times by 10 meters per second at 5 times by minus 20 because it's in the opposite direction. And m1 plus m2 is basically the sum of the masses of the before collision, that is 2 plus 5, and then multiply it by the speed of the combined particle. And that gives you minus 80 is equal to 7v, and v is about minus 11.42 meters per second, which is 11.42 meters per second to the left. Thank you for watching my video. Have a nice day.